Hi Math 2. This is a video going over some tips to do the practice problems in lesson 3. So for starters, in questions 1 and 2, they give us a table with the original coordinates and the image coordinates. And in the first problem, they want us to complete this table and determine the rule for the transformation. So I'm looking at the coordinates I'm given, and I'm trying to decide what's happening. And it looks to me like my XY coordinates are being flipped. So this side would be my YX. So I've switched positions, same thing here. So it looks like, for instance, with this coordinate right here, if this is 4, 0, then on this side, it must have been 0, 4, so that I could flip them and get my image coordinate. So if I'm flipping my X and Y, this becomes 6, 1. This would have been -2, -1. And it looks like I'm flipping my Y and X coordinates. So let's take a look at question 2. It says, write a rule that describes this transformation. So again, I'm looking to see what happens. I'm looking at each of my coordinates, and I'm trying to examine how everything's changing. It looks like both the X as well as the Y coordinates change. So when I'm looking at the X coordinates, this decreased by 3. -3 minus 3 more would also be -6. 1 minus 3 would be -2. -1 take away 3 more would also be -4. It looks like for my X coordinate, I'm taking 3 away. So now what's going on with my Y coordinate? Well, this was 1, it went to -1. And 4 went to -4. Oh, and -2 went to 2. And -4 goes to 4. It looks like my Y coordinate's staying the same, it's just the opposite sign. So I'm multiplying whatever my Y coordinate is by a negative. So it looks like my missing rule for this transformation is XY goes to X minus 3, -Y. Okay, ladies and gentlemen, it says select all transformations that produce congruent images. Those have to be rigid transformations, and we have 3 of them. Rigid transformations are things like a reflection, a rotation, or a translation. A dilation doesn't produce a congruent image. A dilation produces a similar image. And a horizontal stretch would be one in which my horizontal coordinate, which is my X coordinate, a horizontal stretch is when I multiply my X term by something, but I don't also multiply my Y term by that exact same number. And so I'm stretching my object horizontally, but it won't be similar because I didn't stretch my vertical direction the same way. So let's take a look at your number 4. So it says here are some transformation rules. For each transformation, first predict the image and then compute the coordinates. So there's actually 3 problems here, and you're going to need 3 tables. So you'll need a table for A. So this table has my XY column, and then my other column is X minus 4, Y minus 1. For B, I'll also need a table. This table will have my XY column, and I'll have my YX column. And then lastly, I'll need a table for C. That table also has an XY column, and it goes to 1.5x and 1.5 times y. And for all of these, I have 3 coordinates because this is a triangle with 3 vertices. I have A, B, and C. So I'm going to do B with you, and then A and C are in the locker. You can check your answers. So A, B, and C. So I need to go get my coordinates. Looks like A is at 2, 3. B is at 4, 2. And C is at 3, 5. Okay. So now it's asking me to do the process of flipping my coordinates. So this would become 3, 2, this would become 2, 4, and then I would have 5, 3. Okay, and I need to graph that. So let's do that. So 3, 2, would be this problem's A prime. And then 2, 4 would be this problem's B prime. And then 5, 3, 5 up 3 would be this problem's C prime. I'm going to lightly join those together. And then let me shade this in a little bit. My triangle has flipped over my other triangle. This is actually a reflection. This is a reflection over the line y equals x. And now this is going to last year to algebra. Y equals x is the line that goes through our origin and goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. The line goes on forever and ever. So what I've really done, if you can imagine folding my black triangle and my blue triangle up on that red line, my C and C prime would match, my B and B prime would match, and my A and A prime would match. So this problem B was a reflection, but not over the x-axis or y-axis like you've been doing, or over, for example, a line x equals 3 or y equals -1 like you've done in lesson 2. This was a reflection over the line y equals x, one that you're a little less familiar with, but we did look at that line last year. So you'll need to do A and C and graph them. You might use different colors. That might help you keep those two straight. So it looks like 5 is a bit of a reminder of our volume unit, unit 5, lesson 13. It says a cylinder has a radius of 3 and a height of 5 inches. A cone has the same radius and the same height. Find the volume of the cylinder. So I'll remind you guys the volume of a cylinder is equal to pi r squared h. The volume of a cone is equal to 1/3 pi r squared h. Excuse me. So I'm going to plug in my radius and my height and compute my volumes for each. And then what fraction of the cylinder's volume is the cone's volume? That should be an easy answer looking at those formulas. The answers are in the locker for you to check yourselves. So number 6, I'm going to let you do number 6 on your own because it's a problem that you've done before in lessons 1 and 2. But let's start out a few things. First of all, it wants you to reflect over the line x equals -2. Remember what that is. That's a vertical line at x equals -2. So if I draw in my vertical line, I'm going to reflect my triangle ABC over this one. My triangle will be over here. So this is 3 away. 1, 2, 3. That would be my A prime. This is 1, 2, 3, 4, 5 away. So I would have it 1, 2, 3, 4, 5 away. And this would be my, did I count 5? 1, 2, 3, 4, 5. That's better. This would be my C prime. And my B is 4 away. And so 1, 2, 3, 4, and I would have my triangle here. So now, ladies and gentlemen, when you get ready to do the next part, it asks you to flip your triangle, reflect it over x equals 0. X equals 0 is another way to talk about the the y-axis. So when they say x equals 0, like this is the line x equals -2, when they say the line x equals 0, they're talking about the line that goes through x equals 0 on the x-axis, and that would be the y-axis. So now I'm going to flip this same triangle over the y-axis, and it's going to wind up somewhere over here. So take a look at that, and then think about how could I have done that? Your triangle will end up somewhere in this space. How could you have done that in a single transformation? In other words, how could you have gone from this triangle to the one right there? The answer's in the locker, and if you have any questions, don't hesitate to come to office hours. And lastly, this is really a blast from the past, Unit 1, very beginning of the school year. It says in the construction, A is the center of one circle, B is the center of the other. It says explain why the segments AC, okay, A to C, BC right there, AD, AD right there, BD right here, and AB, why they all have the same length. So look at that picture for a moment, look at your two circles with centers A and B, and see if you can remember why these distances would of course all have to be the same. Again, the answer's in the locker for you to check yourself. Thank you.